Hello, this is Mrs. Ross again with Lesson 12. We're going to do some problems about comparing and elapsed time problems. We did some in the practice set, and we'll do more in the starred problems. So these are Lesson 12 starred problems. You can find them on page 85 of your Saxon Course 2 textbook. Here we go. All right. In 2003, I don't know if I'm going to need that number, the U.S. imported 1,870,000 barrels of crude oil per day. I'm pretty sure I'm going to need this number, so let me see. So if this is millions, and this is thousands, millions, thousands, and this is hundreds, let me fill this in. So 870,000. I'm sorry. Keep reading, Mrs. Ross. Okay, I got it. So in 2003, we have 1,870,000. Got it. Okay. I'm going to change colors to do 1988. So in 1988, the U.S. imported only 911,000 barrels per day. Okay, so 1988, if we do the same thing, if I do, this is thousands and this is hundreds, and it doesn't say millions, so I'm not going to put the millions in there. 911,000. Okay, so 911,000. How many fewer barrels did the U.S. import in 1988? So I want the difference, which is the answer to a subtraction problem. Okay, so I'm going to plug this into my calculator. I think it'll take all of the numbers. Minus 9110, oops, 000. And I got 959. So in 2003, they imported 959,000 more barrels of crude oil than they did in 1988. All right. Number 2, West Street Middle School received 18 new computers for the Media Center. Now there are 31 computers in the Media Center. How many computers were there before the new computers? So we have the old computers plus the new computers equals the total computers, right? And we got 18 new, so I'm going to plug that in. Old plus 18. And that gave us 31. So we're looking for how many old computers there were before. So I can also write this as, oh, this is going to be ugly. For old, let me use x. So x plus 18 is equal to 31. So this just becomes one of those addition problems with an unknown. We do the opposite of addition, which is subtraction. We have to do that to each side of the equals. My x comes down. My equals comes down. 18 minus 18 is nothing. And 31 minus 18 is something. 13. So there were 13 old computers in there before they got the new 18 computers. Let me change colors. William and the Normans conquered England in 1066. Okay, that's great. The Magna Carta was signed by King John in 1215. How many years were from 1066 to 1215? So I'm going to subtract because I'm trying to find the difference. And it was almost 150 years. 149. All right, let's change colors. Number 4, the Colosseum, built by Romans in the 1st century A.D., could seat 50,000 spectators. I don't know if that's a number we need, but I'm going to circle it. The Los Angeles Colosseum, built for the 1932 Olympics, could seat about 105 spectators. How many fewer spectators could the Roman Colosseum seat? So we're looking for the difference between these two numbers, which is the answer to a subtraction problem. So I have 105,000 at the Los Angeles Colosseum and 50,000 at the Roman Colosseum. And I get 55,000 more at the Los Angeles Colosseum. Okay, Change colors. Write a word problem about separating that fits this equation. $20 minus something is equal to $17.13. Let's see. Let's say that Mrs. Ross goes to Office Depot. That should probably be capitalized. For supplies. She has $20 when she walks in. She leaves with, I know you can't read this, but hopefully you can hear it. So she leaves with $7.13. How much did Mrs. Ross spend? Ross, that's me, spend in Office Depot? Not enough. I love office products. Okay, so it doesn't tell us to solve this, so I'm just going to keep my little narrative right there. We'll go on to the next problem. Number 7, 23,000, which looks like this, is how much less, so we're going to want the difference, the answer to a subtraction problem, 1 million, which looks like this. So let's write, and it says use words. So first we're going to use numbers, and then we'll figure the words out in a minute. Minus 23,000. So 1 million minus 23,000. Okay. 977,000. So really the words are how you would actually say it out loud. So when I say 977,000, that's how you would write it. All right, let's do number 10. 10 says draw and shade circles to show 2 3/4 equals 11. So 2 3/4, so 2, and then this one's in fourths. So this whole thing is shaded, and this whole thing is shaded, and we have one of these. So we have 3 that are not. And then 11/4, let's see. That's 4/4, 8/4, 12/4. Is that right? Yeah, it is. So this is 3/4. My bad. There's only one little, and all of this, and then, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and they look alike. I think there's one problem like this on one of your tests, so it's not a very common problem on your tests that I remember. 11a, what fraction of the triangle is shaded? So we have part over whole. 1, 2, 3, 4. So we have 4 total parts. The shaded are 3, so 3/4. What percent of the triangle is not shaded? So I know that 1/4 is not shaded, and if I look at my poster in the classroom, I know that that's 25%. Or you can divide 100 by 4 and get 25. All good things. Ooh, okay. So 21 is adding and subtracting with the same denominator, same bottom number. We're going to do, because of PEMDAS, we're going to do the parentheses first. So 3 plus 5 is equal to, this is 8/9. So I have 8/9 minus 8/9 is equal to 0. Or 0/9, which is 0. Okay? And what they're showing you with 21 and 22 is that the associative property doesn't work for subtraction. So you'll see that they're the same numbers, but they've changed the parentheses, which is associative property. So here we have to do this part first. We have 8 minus 3, which is 5/9, plus 5/9 is equal to 10/9, which is equal to 1 1/9 if you divide it out. So, okay. Let me change colors. Awesome. 23. multiplication. So we're going to multiply across the top and multiply across the bottom, and then we're going to simplify. So 9 times 3 is 27. 2 times 5 is 10. And then when I divide 27 by 10, I get 2 7/10, which is going to be my answer. 24, I'm going to pull that down here. 15 divided into 37/20. Oh boy. Okay, so 15 goes into 30 twice. And I'm going to have to put this decimal right there. Okay, 37.2. Actually, I'm just going to divide it. Okay, so this is going to be 4, which is 60. I get 120, and then I get 8, which is 120, 0. So I get $2.48. All right, number 25. Divide 14,847 by 9 and express the quotient, which is the answer to a division problem, as a mixed number. So 42847, we got this. 9 times 4 is 36, 5 is 45. So this is going to be 4. 1268. 9 times 7 is 63. 8 is, okay, 7. 54. 9 times 6 is 54. And that's going to have to be 0. It doesn't go into 7 at all. So we have 7 left over. How do you like how this just goes like this? Isn't that interesting? And 7/9. All right, let's go on to the next one. All right, last page. 27 says, find the next 3 numbers. Where is my... There we are. Find the next 3 numbers in the sequence. So I have 1/4, 1/2, and 3/4. Now 1/2 can also be written as 2/4. So I would have 1/4, 2/4, 3/4, and in the next 3 numbers, 4/4, 5/4, 6/4. So this is interesting because 4/4 is going to be 1. 5/4 is going to be 1 and 1/4. And 6/4 is going to be 1 and 2/4, which is 1 and 1/2. Okay, so we have 1, 1 1/4, 1 1/2. Holler at me if that does not make sense. How many 2/3 are in 1? Remember, we flip it. 3/2. Because 3/2 times 2/3 is 1. 29, write 1 2/3 is an improper fraction and multiply the improper fraction by 1/2. So we have 2 parts here. We have that we're going to change this to improper fraction and then we're going to multiply. So let's do part 1. 1 2/3, we're going to popcorn it times, add 3 times 1 is 3 plus 1 is 5. And then I have to take this and multiply it by 1/2. Times 1/2, so multiply across the top. 5 times 1 is 5. 3 times 2 is 6. This is it. Answer, answer. Last one, and I'm going to have to escape out of here so I can use my inch ruler. Hold on just a minute. All right, last one says, using a ruler, draw a triangle with that has 2 perpendicular sides. We know that that means 90 degrees. One is 3/4 of an inch. And one is 1 inch long. So let's do this. Let's put that there. And I'm going to click the draw function here. So 1 is 3. Oh, no, I don't want to. Okay. 1 is 3/4 right here. And then I'm going to flip this. Is it going to let me? Let me have it. Thank you. Flip it. Yay! Look at me go. And put that there. And then I'm going to draw again. Let's see if it'll let me draw. Oh, no, I don't want to move it. So, oh, that's a straight line. Way to go, Mrs. Ross. 2 perpendicular sides. This is 3/4. This is supposed to be perpendicular. What else does the problem say? My ruler's now in the way. What is the measure of the third side?